Okay, and we'll take our that function with which we started. So as an example, fx equal to box x, also called the greatest integer function. But you know it as box x, and since you know it, read it as box x. Okay, but anyways, the meaning remains the same. So now for this, a to x, a of x is basically, obviously I'm taking some 0 to x box t dt. Again, I cannot write box x here, right? That will make my integral meaningless. So that is, I'm talking about the right side of the graph. I'll draw the graph. Okay, and on the left side, similarly, I can define another integral. So let us draw the diagram above, okay, so that you can understand what we are essentially talking about. Now, box function, drawing a box function is pretty easy, you know that, right? So this will be the first one. If I take the integers, so to say, 2, 3, you know, and -1, -2, -3, if I go that way, okay. So then box function will basically look as we know it, a step function. So here, then here, then here, then here, and so on. And here also I will have this, right? Okay, and then this. So it will go like that. Now, when I'm integrating, what I'm doing is, as we said earlier, this area, then this area, and then this area. Let's say my x is somewhere here. Okay, so I am basically restricted to up to this x while integrating. Now, if I draw the ax, so if this is my fx, right? So if I draw the ax here, how will that ax look like? So it will be like this. So let's first come down. Okay, so let me mark it, -1, then 1, then 2, then 3, right? And then some x, as we have drawn it. So it will go like this, this, then slightly this, right? Okay, yeah, okay. Then it will be along this line because the area will not change, right? 0. So then again, it will be like, so I'm drawing an approximate function. You can understand that, right? So this, then this, and then this. So here I will have the, I have the x here. So it will end somewhere here. Okay, so that that will be the graph of ax if I plot it. And the easy way to understand that graph is basically that here you see the value of ax is not changing. Okay, and this curve on the right side, this is convex, right? Of that there is no problem. So okay, but here the important part is, as I was saying, that the third property, that the integral that we have found, this becomes, as we call it, piecewise linear. So in regression you have seen that piecewise linear regression. So ax basically looks like that. And the important part is that now ax is a continuous function. So that's why I was saying that integral is always a continuous function. It doesn't matter whether you have from where you have coming with the integral. Okay, so even if I start with a function like box x, the resulting ax will be continuous. So the now you probably you understand the idea of using box x, because in case of boxes what happens is you go like this, then there is a breakpoint, and then you start. So this is essentially a discontinuous function, right? But when you integrate it, it becomes continuous. Okay. And also, as I said, that the idea, the property related to convexity and concavity, they are very important.